When we're writing a word problem for inequalities, we could have multiple steps. So we're going to look at some word problems that would result in a two-step inequality. And we're going to read through these the same way we did with one step, keeping an eye out for those keywords. Is it talking about something with a total that typically goes at the end? And again, we can always plug in sample numbers to test out what operation we should use. Just like with one-step word problems, every word problem is going to be a little bit different. We're going to start with just 3 examples. So we're going to start with this one. On a field trip, there are 9 students per group. Typically, when it's telling me per group, per something each, I'm going to multiply. So there's 9 students per group, so 9 times the number of groups. We'll use G for groups. You could plug in a sample number. So if you weren't sure that you should multiply there, you plug in a sample. If I have 3 groups, I would have to do 9 students times 3 groups. So that helps me figure out the times and then plug my G back in. There are also, additionally, there are 8 adults on the trip. If there are less than 60 people, so this has to be less than 60 people on the trip. It does not say it could equal, so we don't, just strictly the less than sign. Next one. Brett already has $30 saved. He's got $30. He plans to save $20 per week. There's that per week, so per for each, typically need to multiply. So we already had $30. He's saving an additional $20 for each week, so $20 times the number of weeks. He needs to save a minimum. So here's a 415, that's my total. Total typically goes at the end. A minimum of, so he could save the 415, but that's the minimum amount. That means he could save that much, but he actually wants to save more than that. So greater than or equal to. That makes 415 the minimum, the smallest, which means he has to save that or more. And we'll look at one more example. A family has $60 to spend at a theater, so that's their total. They've got $60 to spend. If they already purchased 4 tickets that were $12 each, so that's a lot of numbers, but that's telling me how much money I've already spent. I've already spent this much money. 4 tickets that were $12 each. There's an each, or per. So it's $12 times the number of tickets, but I know the number of tickets. The number of tickets is 4. So that's actually not going to be a variable. $12 each, 4 tickets. So then I just have to do $12 times 4 tickets, and that's going to be 48. So that means they've already spent $48. How many packets of candy? So they're going to spend more money because they're going to spend money on candy. $3 each. Now this is going to be our variable because we don't know how many packets. Unlike we knew the number of tickets was 4, it doesn't tell us how many packets. So $3 each, we'll use C for candy without going over budget. So they could spend exactly 60, but they can't go over 60. So they have to spend less than 60 or exactly 60 to make sure they don't go over their budget.